Hey guys, in this video, Physics in the Flesh is going to do a potential energy problem. A 1300 kilogram car rolling on a horizontal surface has speed v equals 60 kilometers per hour when it strikes a horizontal coiled spring and is brought to rest in a distance of 2.1 meters. What is the spring stiffness constant of the spring? Okay, so this question is going to involve something called conservation of energy. Okay, so in physics, we say that the amount of energy in the universe cannot be created or destroyed, the total amount. It's always going to be constant. Okay, so that means that we can say that the total energy of a system in one place is equal to the total energy of the system at another place. Okay, so you pick 2 points on the problem that are most useful to you, and you can set those two total energies equal to each other. This is a very, very handy statement, and I'm going to show you how to use it for this problem. Okay, so let's draw some pictures of what's going on in this problem. So we start off with the car driving on the horizontal surface, and there's a spring here, a horizontal spring. It's just out there. Now this car is going forward, and it's going forward. It has a speed. I'm going to call the speed V1, 60 kilometers per hour. Okay. Initially, the spring is not compressed or stretched, so the amount by which it's stretched or compressed is 0. So x1 equals 0 meters. Okay, that's initial. Afterwards, it says the car is brought to a rest, so that means and implies that the spring is, well, compressed a bit. Okay, so now we've got a compressed spring, and we've got the car in front. The car is brought to a stop, so now V2 is 0 kilometers per hour, or 0 meters per second. And we're told in the question that the car is brought to rest in a distance of 2.1 meters. So if the car stops in 2.1 meters, that's also the same amount by which the spring compressed. Okay, so x2 equals 2.1 meters. Now, the first thing I realized when I see this problem is I'm given a speed in kilometers per hour, and we know that you want to always deal with SI units. So let's convert this to meters per second. And let's see, so we get 60 kilometers per hour. And now converting it requires 2 steps because we have kilometers and hours. We need meters and seconds. So we multiply it by 1 twice, 60 kilometers per hour. Now the reason I multiply it by 1, if you multiply by any other number, you're going to change the value, which you don't want. And you have to pick your 1 to be useful. So you don't want to write 2 over 2 or 6 over 6 because that doesn't help you. But you can write something like this. 1 kilometer is identical to 1,000 meters. In other words, the numerator equals the denominator. That's equal to 1. Okay, that's to get rid of the kilometers. To get rid of the hours, I'm going to say that 1 hour, and I need seconds on the bottom, is equal to 3,600 seconds. Okay, so by doing that, you cancel out the kn, you cancel out the h, and you're left with m over s. So 60 times 1,000 divided by 3,600. You're going to get your V1 to be 16.7 meters per second. So that's good. We can now use this in our problem. I'm going to go ahead and work with my conservation of energy here. Okay, and let's figure out again, what is the question asking for? It's saying, what is the spring stiffness constant? That's K. Okay, so let's start with our conservation of energy expression. Let's do that right here. So ET1 equals ET2. So these are the 2 stages of the problem I'm dealing with. This will be 1 and this will be 2. Okay, so I've already identified the various variables for this. Now, you might have seen in previous problems that I labeled the speeds as V0 and V. The reason I'm doing V1 and V2 here is because as you do more problems like this, specifically, let's say roller coaster problems where you have many different parts of the motion, you'll have 0.1, 2, 3, 4, and you don't want to use V0 and then V, and then it gets a little bit strange. If you're comfortable doing that, by all means, go ahead, but I prefer to now start incorporating numbers like 1, 2, 3, 4. Okay, ET1 equals ET2. Now, the 2 types of energy we're dealing with in this problem are kinetic, the energy of motion, and spring, or elastic energy. Okay, so initially, let's say we have kinetic and spring energy, and finally, kinetic and spring energy. So EK1 plus ES1 equals EK2 plus ES2. I always find it best to write everything in the beginning. You can always cancel stuff out later on. Okay, so the formula for kinetic energy is 1/2 mv squared. And because it's initial kinetic energy, we want to put a 1 there for the V. Spring energy looks actually very similar to this. It's 1/2 kx squared. In fact, it's going to be kx1 squared equals 1 half mv2 squared plus 1 half kx2 squared. So the first thing I notice is I have a 1 half in every single term. Imagine factoring that out on both sides and then dividing both sides by a half. Everything's going to disappear. If you have something that appears in every single term, you can cancel it out. Okay, so I'm just going to take care of those first. The next thing I know is that, well, you know what? My initial compression is 0. So if x1 is 0, 0 squared times anything is 0. So this whole thing disappears. And I know v2 is 0. So if v2 is 0, same idea. This whole expression disappears. So look, you went from something so long to this. Now you're left with mv1 squared equals kx2 squared. And all you need to do is find k. So I'm going to divide both sides by x2 squared. And I'm going to bring the k to the left just so it looks a bit neater. K is equal to mv1 squared over x2 squared. Plug in your values. Okay, so your mass is 1,300 kilograms. Your initial speed, we converted to 16.7 meters per second. Make sure you square that because often people forget that part. x2, the final compression is 2.1 meters. That also gets squared. So all you have to do is plug that in your calculator and you will get a value of k is equal to 8.2 times 10 to the 4 newtons per meter. Okay, so there you have it, guys. I hope you enjoyed the video. If you did, be sure to smash that like button. And stay tuned next time for video 106, Potential Energy 2. Hey guys, welcome to the end screen. Woo, I got you guys. All right, here's what I need you to do. Subscribe to this channel. Okay, I'll stop. Thank you guys so much, as usual, for watching. If you guys enjoyed this video, be sure to subscribe to my channel by pressing that red subscribe button below and smash that like button so that I know what I'm doing makes sense to you guys. First face reveal I do in my hair is all frizzy. I post new videos every weekday at 12 noon. Finally, guys, I love you so much for watching. Please continue to do so every weekday at 12 noon.